Hey everyone, this is Steven, StoicDev0 on Twitter. I am a Solidity dev at Remark, co-author of the EVM implementation of the protocol, together with 3 merged AIPs. This is part of the first project series, where I teach you how I build Snake Soldiers. Remember, this is a personal project, it just happens to use Remark. In the previous video, we learned how to use the catalog and how fixed and slot parts work. In this video, we will focus on the deploy script. The first thing we will do is to import some types. These are generated by the typechain library, which is already configured on the EVM template. So these are generated when you compile and are super useful when you're using TypeScript because they give you auto-completion of each of the methods these contracts define. We're also importing some constants we defined on the previous video. I have 2 files for them. One for the general constants, where I can easily edit them all in a single place. Another one for the catalog constants, which contain all the IDs for each of the parts. My main function, when I run this script, will just run this function. So let's take a look at it. The passport and the faction gem contract need to know each other, because the gem can only be detached from the snake if it holds a passport, and the passport can only be burned from a gem call. But we didn't define methods on these 2 contracts to update the other one. They can only be set on deploy, and we need to deploy one of them first. So we have a bit of a problem. I will fix it next, which is to add in both contracts an option to update. So on the Serpentora passport, let's create a function set faction gem, thanks GitHub, and I will actually call it here. It should reduce the size a bit. We could just leave it there, but I want to be sure I can update this in case something goes wrong with the passport contract, so I will do it also on the faction gem. So I'll create this function here and call it, and I have a problem here because I had made this immutable. Let's just remove it. Should all be fine now. I call the typechain command so it updates the types, and let's go back to our deploy. So here we will deploy with address 0 at first, but then we've already fixed this, and I think we called this, and that's it. We already have. Let me just show you how typechain works. Each of this function, actually most of them actually exist on the passport. This is pretty useful. Let's go back to where we were. We deploy the passport. We simply deploy each of the gems with all the data we already defined the constructors would get. In the faction gem, we include the passport address, we already have it at this point, and the catalog, which just receives the metadata URI and the type. Type here, just let me show you, is the type of content this catalog will use. In our case, it will be image PNG. We wait for all of them to be deployed. We updated the faction gem as we saw just seconds ago, and we print each of the contracts so we can keep track of them for our UI. Let's do a test deploy. You can use this with yarn or npx, and setting the script you will deploy, but it must not receive any arguments. And this is the result. It's deployed locally, so we cannot do much with it, but I always do this before going to an actual test network because I can detect problems earlier. When I want to deploy this, for instance, in Moon Alpha, I would just do this, Moonbase Alpha I mean, and it will run the deploy. Let's go back for a moment to our base gem contract, where we had defined this add asset entry, but which was actually receiving all the equivalent information. What we meant to do actually was this. With that in place, I've created this script to add the main assets. So if you remember, we had assumed here that these assets would exist on the snake. By adding them here in the right order, we guarantee that they will have the expected IDs. Similarly for the gems, we expected the main asset ID to be 1. By being the first we add, we guarantee that it will be the expected one. Going back to our deploy script, I imported the function we just created and the configure catalog we saw in the previous video, and I will simply run them here after we've deployed all the contracts. There's one last thing I want to show you. In case you want to verify your contracts directly on this script, even though you can also do that later from the command line with the verify command, I find it just easier to be done here because we have all the information. So we import run from Hardhat, and we simply run this command. We pass the address of the contract we're trying to verify and the constructor arguments. They of course must match exactly what we used to deploy. This will take a bit, and then your contract will be already verified and you can check it on Moonscan. If we try to run this locally, it will fail because there is no much sense on trying to verify on a local network which just is running just on the duration of the script. So never mind that, but we will actually need this when we're running on actual blockchains. That's it for the video, and you're now ready to create and deploy your own custom contracts using the most advanced NFT protocol in the world. Please leave any feedback and questions in the comments. I'll happily review them and answer your doubts. Remember, the code after each video is added to GitHub so you can follow step by step. There's one video left, probably the most important, where we will see how to test these contracts. This is the same as testing any other contract, but I want to include it in the series because I really don't want to see projects using Remark failing due to some stupid error that could have probably been prevented with a good test suite. See you there, and thanks for watching.